Welcome to Spring LIB.
So in this question, we have 4 parts. The first part is talking about audible sound, which it has the range between 20 Hz to 20 kilohertz. Speed of sound in air is 344 meters per second. Now we're looking for these limits in terms of wavelength. So lambda is equal to the speed of sound in air divided by the minimum limit for frequency, which is equal to 344 meter per second divided by 20 hertz, and that's equal to 17.2 meters. The other limit, lambda, is equal to V divided by F max, which is equal to 344 meter per second divided by 20 kilohertz, so 20 times 10 to the power 3 hertz, and that's equal to 1.72 times 10 to the power minus 2 meters. So as we can see here, the audible sound will has the range of 17.2 meters to 1.72 centimeters. So this is the maximum limit. So this is max and this is minimum. And the fact that we have maximum wavelength related to minimum frequency is because they have an inverse relationship. The second part is about visible light. Now, in general, electromagnetic waves and light has the speed of light in vacuum, which is 3 times 10 to the power 8 meters per second. And the visible light is between 400 nanometers to 700 nanometers. Now, nano means 10 to the power minus 9. That's the meaning of nano. Here we're looking for the visible light limits in terms of frequency. So frequency maximum is equal to the speed of light divided by lambda minimum. And this is because, again, they're related to each other by an inverse relationship. So 3 times 10 to the power 8 meter per second divided by 400 times 10 to the power minus 9 meters. And this will be equal to 7.5 times 10 to the power 14 hertz. The minimum limit, so minimum is equal, the frequency minimum is equal to speed of light divided by lambda maximum, which is equal to 3 times 10 to the power 8 meter per second divided by 700 times 10 to the power minus 9 meters. And that's equal to 4.3 times 10 to the power 14 hertz. So this is 14. So the visible light is between 7.5 times 10 to the power 14 hertz and 4.3 times 10 to the power 14 hertz. Okay. Now, then the last 2 parts of this question are talking about surgeons when they're trying to get rid of a tumor, a brain tumor. Sometimes they're using ultrasound. Now, the frequency of the ultrasound they're using is 23 kilohertz, which is above the audible sound limit. Now, in part C, we want to find the wavelength of that ultrasound in air. So V air divided by frequency will be equal to 344 meter per second divided by 23 times 10 to the power 3 hertz, and that's equal to 1.5 times 10 to the power minus 2 meters. So this is my answer. For part D, now when the ultrasound hit the human body, it will move with a different speed, and the speed of sound inside the human body is 1480 meters per second. So the wavelength of inside the human body is equal to V body divided by the frequency. Now here, because we didn't change the sound, it will have the same frequency and it will have the same energy. So V body is equal to 1480 meter per second divided by 23 times 10 to the power 3 hertz, 3 hertz, and that's equal to 6.4 times 10 to the power minus 2 meters. So this is the wavelength of the ultrasound that they use to get rid of a brain tumor inside the human body.